Hello everyone, my name is Malik and you're watching Malik Robotics. So, in this video, we are going to manipulate some tensors. We will see that what are the some fundamental things on or property of the tensors, and we will also do some dot products and other mathematics on the tensors. So, without wasting much time, let's go. So, the tensor have the four properties: shape, rank, axis, dimension, size. Okay, so first of all, what is shape? Shape is nothing the all the dimensions of this array. Like this tensor have the shape 3, 2, 4. Means like this is 3, this is 2, and this is like where is 4 here? All the image is 3 to 3, but okay, let's consider this is 3 to 4. Okay, so shape is the whole shape of the tensor. Rank is the number of the dimension present in the shape. So here this is there are three things, and in the computer science we start indexing with 0. So this is 0, 1, 2. So this is the two ranks tensor. Now what is the axis? Axis is any one axis of the tensor. Here one axis is 3, like sorry 0, 0 to axis is 3, first axis is second, and second axis is 4. So these are individual axes of the tensor. And the size is whole size of this tensor. Like the size is 3 into 2, that is 6, 6 into 4, 24. The size will be 24. So these four things we have to keep in mind, that what is the shape of the tensor, what is the rank of the tensor. Like a scalar has rank 0 because it has only one value, and a vector has two values, so it's like rank is 1, and a matrix which has three values, its rank is 3, and so on. So shape, rank, axis, or dimension, sorry, and size. So we will keep in mind these four things. Okay, so let's see what are the in the code part. So let's jump to the code. Okay, so we will first clear out the output, and now we have imported TensorFlow as TF, and I have written this like what is shape, what is rank, what is axis, and what is size. So shape is like this: 2, 3, 4, 5. This is the shape. Rank is actually what is the dimension. Like here 1, 2, 3, 4. 4 axis means 4 dimension, means 4 rank. Okay, axis is like 2 is one axis, 3 is also one axis, 4 is also one axis. So this all are axes. And size is like 2 into 3 into 4 into 5. Okay, so let's create our rank 4 tensor of shape 2, 3, 4, 5. We have used tf.zeros. What tf.zeros does, I have taught you in previous video that it give the zeros in the shape of 2, 3, like what the shape you applied. So here we got zeros, 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 and 2, 3, 4, 5. Now we will see the data type. Number of dimension means rank, shape of tensor, element along 0 of tensor, and like last axis, this is the first axis or 0th axis, and this is the last axis, and total number. Okay, for data type we will use .d type, which is the TensorFlow function which tells what is the data type. This is the endem, also a TensorFlow function which tell number of dimensions so that we can get the ranks. .shape function tell that the what is the shape of a function. .shape 0, this will give the 0th or first part of the shape. This will give the last index of the shape. Like 0 to give will this, and -1 will give this. Okay, now here what I have done is like tf.size. This will give the size of the our tensor, means 2 into 3 into 4 into 5 of rank 4, because rank 4 tensor is of this shape. And after this will convert into numpy, as numpy is much faster for calculation. So here we have 4 dimension rank or 4 rank. Number of the shape of tensors is 2, 3, 4, and 5. Element along x-axis 0 of tensor is 2. Element along last axis is 5. Total number of elements is 120. So This I already taught you in the slide, so you don't have any question in this. So let's move on to the other things. So let's say we only want the first two items of each dimension. So we just have to use this. Like you all, if you have learned the Python, you know what is the string slicing. Uh, colons to. This means that all till means 0 and 1. Like all before this. Okay, let's see. So this is 0 0 0 0 0 0 0 0 0 0 0 0. So we have got all the two items of each dimensions. Okay, now we will create a new two rank tensor or two dimension tensor. This is okay. So it dimension will be 2 comma 2, and let's make. Why this is giving 2? Because we have only taken the last item, which is 7 comma 4. So this was all about what is rank, what is dimension, shapes, and now we will do some manipulation. Before that, this is something how to make an extra axis. Okay, there is a function tf.newAxis. So we just have to give our rank to tensor, and the square bracket, in the square bracket we have to put 3 dots. 3 dot means all dimension prior to. So rank 3 tensor will have all the prior dimension of rank 2 plus 1 extra dimension. So this will be the shape like this at final. So from this we have made this, from this we have made this, an extra dimension. But I know this is something a complicated part of code. For easy, we have a function tf.expand_dims. This gives us a new dimension on the axis which we provided, like -1 last axis. So you can see we have got a similar result as they work very similar. Okay, so this was all about some basic quality of tensors. Now we will manipulate some tensors. Okay, so we have make a tensor of rank 2 or a matrix. Okay, and then we will plus 10. This is how we can plus the and matrix just as it is. Like we have given a matrix and then plus 10. 10 plus 10 20, 7 plus 10 17, 3 plus 10 13, 4 plus 10 14. Just like original was 10 7 3 4, and our plus 10 will give this. Same with multiplication, we have 100 70 30 40, and same with subtraction. Okay, now you can see that we have same result. Why? Here we can either multiply by 10 or we can use tf.multiply. This is our TensorFlow function. This just in here we have to give the tensor and then the value from which we have to multiply. So it gives us the multiplication part. Okay, now matrix multiplication. First of all, you will say ask Adam, what is matrix multiplication? Okay, here before what we were doing, we were just multiplying one thing to the all the matrix, like 2 into 4, 2 into 0, 2 into 1, 2 into -7. Okay, so this was what we were doing before, but now we are doing matrix multiplication. Means we have taken one matrix and we have taken another matrix. So this is how we are doing. Okay, in matrix multiplication we will do dot product. What is dot product? In dot product we do nothing, just take first element of here, multiply with this, then take second from here, then multiply with 9, then 3, then 11, and just we will plus, like 1 into 7 7, 2 into 9 80, 9 to the 18, 3 11 to 33. We will plus and it will give 58. Then we will multiply this to this, then we will get this, like this to this, then we will get this to this, we will get this. Okay, so one catch is here is like, so I'm multiplying this to this. So remember that if it is n into j, then this has to start with j into anything. means its last part, like n into j, means j is the this dimension. Okay, rows 1. So this, the number of element in rows of this matrix, first matrix, should be number of element in column of second matrix. Okay, then only we can do dot product. If our this was 4 and this was 3, we got some error. So this is how. Then we will do with this and 64. Okay, so this was all about the dot product. Let's jump to the code. Okay, here we have tf.matmul, which will give out the matrix multiplication. You can see, like, we don't have to multiply everything and add all things. We have here tf.matmul. We can use tf at the rate. This also give the dot product of the two matrix. Okay, so here we have create two matrix 1 2 3 4 5 6 7 8 9 10 11 12. Now, will it multiply or not? These are of same shape, 3 comma 2 3 comma 2. But what I said, if here there's 2, then here it is should be 2. So if I multiply or multiply this matrix, this will give some error. So for what we have to do? Then we have to reshape it into 2 comma 3. Now it is 2 comma 3. Now can we, you can see, we can have a matrix multiplication, or what we can do is we can take transpose. What transpose does, transpose just convert it into like 7 8 9 10 11 12. It just rotate, tilt it, it will be 7 8 like here. Okay, 7 8 9 10 11 12. Okay, 7 8 9 10 11 12. So it just tilt it. And if so, there are some results that we can reshape it, and then we can matrix multiply, we can transport it, then we can matrix multiply, we can do anything, and we can make a matrix multiplication. Just you have to remember that if it does first shape is 2 comma 3, then other shapes will be 3 comma anything. So the row number of rows, the first matrix should be number of column in the second matrix. Then only we can multiply two matrix. Okay, so this is the other thing in tf.matmul. Like, we have taken a equal to x, b equal to y, and we have taken transpose of 1. Means we can say that we have to try to transpose it true and transpose of b equal to false. It will give the same result. And these are the some basics, different ways. Like, we can use add the rate, we can use dot mat multiply, we can transpose, we can reshape, you can do anything, but what you have to do is just see that number of rows and number of columns should be matched. Now we can use tensor dot. Okay, what does this? tf dot transpose x, it transpose our first matrix, and then y. Okay, y should be like one of these should be transposed, then also only we can get the right shape. Now, and don't take tension that what is tensor dot. This is only matmul, like two functions doing the same things. Okay, so now y shape is 3 2, and tensor shape is 2 3, and y shape tf dot reshape y, and tf dot transpose y dot shape. This is the part where I am showing that if you did tf dot reshape, then also we get the same shape, and if we will do tf.transport, then also we get the 2 3. Okay, so this was all about dot product and multiply, like you will say that rhythm. If these all are doing same things, then why you have done so many things? Because this course is generally focused on TensorFlow, so I should teach you everything of TensorFlow. And when you will try these all the function, then if you are reading someone else code or checking it online, then you will not get confused. So this was all about the manipulating tensor part. After this, I think we will cover one more video in the that also consists the this type of operation of TensorFlow, and video after that will consist of the regression part. Like we will then jump on the real neural network problems. So let's end the video here, and we will meet you soon.